Okay, this video we're going to get serious about digitizing, and we're going to use some high resolution imagery that I obtained from the city of Arcata. Yeah, pretty sure. It's like 3 inches. It's really cool stuff. And I'm going to show you first how to add a folder connection to get to this data if you're inside the HSU firewall. Note that we have a network drive out here. It's actually called Academic Storage, or Drive L. Ooh, GIS data. And I'm just going to go ahead and mount that drive. Sorry, add a connection to ArcGIS to that drive. And then you're going to see there's a bunch of data that we have available. Here's the city of Arcata. And then here's that 3-inch data. And if you're on this drive, you can go into Ortho, and then you can go into a geodatabase. GDB means geodatabase. So this is a folder that has an Esri unique geodatabase format, and this little icon here means this has a bunch of images. In fact, it has all of these images. These are the individual tiles for the 3-inch data. It's a big data set. So you can't just drag it around. And this is typical a lot of the raster data sets. And I'm going to pause while it's loading. Oh, wait. Okay. So first, you might wonder, where's the data? Yeah, where is that data? Now, this is kind of typical of ArcGIS. It'll do this. So right now, it's sort of lost and confused. Let's go ahead and turn off everything else that we're not using. Oh, we got the boundary. Oh, wait, I saw a boundary. I know I did. I'm going to pause until things come back. Okay, so I never got to see my photos this way, so I guess instead of using this as a demonstration of how to use the network drive with a geodatabase, it's going to be a demonstration of why not to use that. Rather than sitting here, this is kind of ridiculous. I'm going to do something different. And all right, so instead of waiting forever for that to work, probably the network as well as the data size, as well as ArcGIS being slow were the problems. You got to get past those problems. You got to figure out ways to get past the speed problems and get moving. So what I did was I figured out which tiles I needed. It's tile 18 and 19 from the original data set. Those are the ones that overlap with HSU. I pulled those out of the data set on the network, and I zipped them, and I put them up in our 2020 GSP 510 folder on Google Drive, Lab 5. I then downloaded those to my computer here at home. And you could do this with the virtual machine at HSU. Please don't put them in the folder that you're going to put back up on Google Drive, because you'll just spend all that time with the data uploading and downloading. You can just download it each time. And I'm just going to put it in my GIS data folder and keep it. Brought down the zips, right click, unzip them, extract to, and now I've got the data. Now I can go ahead and drag and drop these into ArcGIS Pro, and you can see it's a little bit faster. Now when I zip them, I also zip the OVR file. That's what actually has the pyramids in it. If you put a big raster into ArcGIS, it'll say, do you want me to create a pyramid? Pyramids are a good thing. Let it create the pyramid. It draws much faster. I just included them so you won't get that dialogue. Now, when we're digitizing this type of data and working with this type of data, you don't want to project it all to your target spatial reference like UTM Zone 10 North. Instead, what you want to do is you want to work in the original spatial references provided with the raster. Okay, so in this case, we're talking Nat 83 State Plane, California. That's a federal identification number, so we don't really say that out loud. Feet. Okay, so Nat 83 State Plane, California, Zone 1, feet. Not my favorite spatial reference, but it's what this data is in. So we want to use it. And then after we do our digitizing, we'll project everything into WGS 84 UTM Zone 10 North. Okay, now, one of the things to know is that to be in that spatial reference, we need to go our map, go properties, and hit coordinate system, right? In the raster it says spatial reference. And here it says coordinate system. Do not expect Esri to be consistent in their terminology, okay? So it's different here, but notice that it has picked up the spatial reference from the first layer that we loaded into ArcGIS. I created a new ArcGIS, new project, loaded those layers. Now I'm all set up. Everything is displaying. That's why it looks good. It's fast. All right. Now let's get started. I have decided to do the music building because I'm the professor and I can do things that are really easy as demonstrations. You will need to do more than just one simple building for this assignment. Okay, there's my working folder. Whoops. I guess I'll just go ahead and add a connection to Lab 5. There's my working folder. I'm going to go ahead and create a new shapefile for points as we've done before. Now, you could set the coordinate system / spatial reference to NAT83 state plane zone 1 and then project your data to UTM zone 10 north. Okay, you can do that. That would actually be the safest thing to do. However, I happen to know that NAT83 is very close to WGS84, so if I digitize in that same one, it should be okay. Now, I recommend testing it, right? Don't just do this, okay? But I am going to have it do UTM zone 10 north. Now, that means I'm going to be relying upon Esri to do projection on the fly. My first one I'm going to do is points, and this is going to be HSU points. Now, for this assignment, I'm giving you some flexibility. If you want to have a separate file for hydrants and light posts and things like that, you can. And I am going to go ahead and create a polyline. Whoop. Making sure to correct the, whoops, no template class. Wait, where is it? There it is. Polyline type. There we go. And then do polygons. Make sure we get the type right. Okay. Run, arc, run. All right. So now I could start my digitizing. But before we do that, we need to take a look at this aerial photograph. Okay. So this was taken by an airplane, which means this was like being taken by your camera, except it's up flying over. And take a look. Here we can see, here's the base of the building, and it's leaning. And it's leaning because the camera was at an angle. If we go down here to BSS, which is a big building, you can see there's quite a difference between the roof and the base. So that means that what we're really going to be digitizing is the roof, and it's not exactly going to be the outline of the building. To do an outline of the building, we really would need to be on the ground with surveying equipment to do a good job. Okay, so this is going to be good, rather spectacular aerial imagery. Those are people, so that's kind of fun. But it's not going to be as accurate as it would be if we were on the ground. For that, we need to take mobile mapping and get our survey equipment out. Okay, I'm going to do this pretty quickly. Now notice, for this music building, there's my outline. Good to check how good I did. Zoom in, hold down C. Oh, and see how good we're doing. We really need to change our symbology. Okay, not bad, but I didn't do great. Right? There's some gaps here and some shadows and things. So I'm not really happy with that. So you can go ahead and just redo it, or you can do vertices, and then you can grab these, move them back over. And this is what I talked about with the accuracy and figuring out how accurate you need it to be, because this is a fairly simple building, and I'm going to go ahead and save that. Clear my selection. Okay. And even on this building, you know, we could really zoom in and really do well. In fact, this is 3-inch imagery, so we could get to the accuracy of the imagery. The imagery is not, you know, 3 inches accurate to the ground. That line I should really fix. Ooh. Not as good as I'd like. Okay. There we go. And again, you can see you can spend an infinite amount of time digitizing. Okay, so there's our polygons. Now we need to go ahead, whoops, sure, why not, and click Save. Save will save it to the shapefile. If it's not saved and ARC crashes, you'll lose all your edits up to that point. Again, we want to go ahead and add, and we'll add a field for a name. That should be a text field. Return. Then we're going to get the area. Since it's an area, it's going to be calculated. Come on, you can do it. It needs to be a double. Okay. And I think that was it. Check the assignment, make sure. Okay. So now we can save those. Go back over here, and you can see that we have our area. Okay. And I ended up with an extra one, but that's okay. Now we can calculate that just as we did for X and Y coordinates before, but now we've got area as an option. Okay, notice it's got units. We do want to make sure that in this case, we are working in meters. And I don't know why it is looking for a coordinate system. Because since we're in UTM Zone 10 North, hopefully it would calculate in UTM Zone 10 North. And there we go.